Good morning friends. Today we are going to study how to trace the parametric curves. So this is the last article in this unit. As far as parametric curves are concerned, we know only the definition. Which equations we call it as parametric equations. So if two variables x and y, so these are Cartesian variables x and y. If these two variables are expressed in same parameter, that is t, then such equations we call it as parametric equations. Now while tracing the curves related to parametric equations, what we are going to do? First, we are going to take derivative with respect to t, that is dx by dt and dy by dt. From that, we can obtain dy by dx, and by using calculation of dy by dx, we can obtain tangents at some special points. And after getting tangents at some special points, we find region of absence. And after region of absence, we can trace the curve. Okay. So let us take first example. Trace x is equal to a into t plus sin t. A into t plus sin t, and y equal to a into 1 plus cos Okay. Now these two variables x and y are expressed in terms of t. So here parameter is t and x and y are Cartesian variables. Therefore, such equations we call it as parametric equations. Now to trace what we do? First, we will calculate dx by dt. So, differentiating this x with respect to t, we will get dx by dt is equal to. So, here it is, if I take its derivative, I will get a into bracket 1 plus cos t. And then differentiate y with respect to t, we will get dy by dt is equal to minus a sin t. So from these two derivatives we can obtain dy by dx. So what is the dy by dx? It is dy by dt upon dx by dt. So which is equal to, so what is the dy by dt? It is minus a sin t divided by dx by dt. It is a into bracket 1 plus cos t. Now when we simplify this, so this a will get cancelled and which is equal to minus 2 sin t by t into cos t by t. So this is formula for sin t divided by 1 plus cos t. It is 2 cos square t by t. So we know these half angle formulas. Now here 2 will get cancelled, 1 cos t by 2 will get cancelled. So here it will remain minus tan t by t. Okay. So we got dy by dx as minus tan t by t. Now after getting dy by dx, we will prepare one table which contains the parameter t, the points x, y, and then the tangent dy by dx. So now we will prepare the table like this. So first row I will take it as t, second row I will take it as x, third row it is y, and then fourth row it is dy by dx. Okay. Now we will choose the parameter t. You can choose from minus pi to pi, you can choose from 0 to 2 pi, any range of interval 2 pi we are going to select. So here I will select values of t minus pi, minus pi by 2, here it is 0, plus pi by 2, and then plus pi. Okay. Now for these values of t, we are going to obtain x, y and dy by dx. Now when t is minus pi, what is the value of x? So sin of minus pi, it is 0. So value of x is minus a pi. For t minus pi, what is the value of y? So cos of minus outside, so it is plus tan pi by 2, and tan pi by 2 it is infinity, so here I will write infinity. When p is minus pi by 2, what is x? A into minus pi by 2 plus sin minus pi by 2, it is minus sin pi by 2, so that is minus 1. When p is minus pi by 2, what is y? So this is 0 and here it is a, so y is a. And when p is minus pi by 2, the value of dy by dx is tan minus pi by 4 minus taken outside, it is plus tan pi by 4, so value of dy by dx is 1. Now when p is 0, what is x? X is 0. When p is 0, what is y? So it is 2a. And when p is 0, what is the dy by dx? It is 0. Okay. Next is when p is pi by 2, what is x? A into pi by 2 plus 1. A into pi by 2 plus 1. When p is pi by 2, value of y is a. And when p is pi by 2, the value of dy by dx is minus 1. Next, when t is pi, x is a pi. When t is pi, so y is 0. When t is pi, the value of dy by dx is minus tan pi by 2, that is minus infinity. Isn't it? So after this table, what we are going to check? We are going to check the region of absence. As here value of y is a into 1 plus cos t, value of y is a into 1 plus cos t, and this is nothing but 2a cos square t by t. So this value of y is always positive because 2a positive and square of cos t by 2, so y is always positive. And if y is always positive, what it means? The curve lies above x-axis. Okay. Now after getting these points, see what this table gives. This table gives the special points and the tangent at these special points. And by using this table, we can draw the curve. Okay. So the final point is shape of the curve. Now the shape of curve is, so here I will draw the shape of curve. So while tracing the curve, what we will do? First we will draw x-axis and y-axis. Okay, x-axis and y-axis. Now we will plot the points and the tangents at these points. The first point is x is minus a pi and y 0. So this point will be here. X is negative and y is 0. Next point is, this point we are going to neglect because here it is a fractional value. This point is 0 to a. So x is 0, y is 2a. So maybe at this distance. Again this point we are going to neglect. This point is a pi 0. So a pi 0 it is on x-axis, and as x is positive, so this point it is on positive x-axis. Now first point, at this point minus a pi 0, what is dy by dx? It is infinity. If dy by dx is infinity at this point, it means tangent is parallel to y-axis. So I will draw the tangent like this. So this is the tangent at this point. Now next point is 0 to a. At this point, dy by dx is 0. If dy by dx is 0 at this point, it means tangent is parallel to x-axis. So this line is tangent passing through this point and which is parallel to x-axis. The last point is a by 0. So at this point, again dy by dx is minus infinity. It means tangent is parallel to y-axis. So this will be the tangent. Now at this point, if this line is tangent, the probable curves are like this, and again like this. Okay. Similarly, this line is tangent at this point. Again, probable curves are like this and like this. This line is tangent at the point 0 to a. So the probable curves are like this. Okay, and again on this side. But here, in region of absence, if we see y is always greater than 0. If y is greater than 0, it means curve lies above x-axis, and therefore I am going to erase this part of it. Okay. So below x-axis curve is absent. So I can erase this. Again I can erase this. Again two curves we have to join. So I will join these two curves. Again I will join these two curves. So here curve lies in between these two lines. So we are going to erase this part also. And such type of curves we call it as cycloids. Such type of curves we call it as cycloids. What is the cycloid? Cycloid, it is the path of a circle along the line. Path of a circle along the line. So when circle rotates, that point it will come here, again it will go up, again it will come here, again it will go up, and that's why I told the range for parameter t you can choose either minus pi to pi or 0 to 2 pi at an interval of 2 pi. Okay. Now the second example is trace x is equal to a into t minus sin t and y equal to a into 1 plus cos t. If we compare this example with previous, the only change is here it is minus sign. Now what we have done? We will calculate first dx by dt. So differentiate this x with respect to t. We will get a into 1 minus cos t. Again differentiate y with respect to t. We will get dy by dt as minus a sin t. Already we have seen in previous example. Similarly, we have calculated dy by dx is dy by dt upon dx by dt. So if we perform the calculations, we will get dy by dx as minus cot t by t. Okay. Now after getting dy by dx, now we will prepare one table. Again in the table, I will choose the parameter. It is from minus pi to plus pi. Now I will find the points when t is minus pi. What is the value of x? It is minus a pi. What is the value of y? So cos of minus pi, it is minus 1 and 1 minus 1 0. So value of y is 0. When t is minus pi, the value of dy by dx it is cot minus pi by 2. So it is minus it will be plus, and then we will get cot pi by 2, and cot pi by 2 it is 1 upon tan pi by 2. So it is 0. Okay. Now for t is equal to minus pi by 2, for t is equal to minus pi by 2, the points are a into bracket minus pi by 2 and again minus of sine minus 90, so it is plus 1. When t is minus pi by 2, what is the value of y? Cos 90 0, so value of y is a. And when t is minus pi by 2, so cot minus pi by 4, then it will be plus cot pi by 4, its value is 1. When t is 0, the value of x is 0, value of y is 2a, and value of dy dy by dx when t is 0. So here it is cot 0, that is 1 upon tan 0. So tan 0 is 0. So its value is minus infinity. Next, when t is pi by 2, what is value of x? A into pi by 2 minus 1. Value of pi, it is a, and value of dy by dx when t is pi by 2. So it is cot pi by 4 and it is minus 1. When t is pi, the value of x is a pi. Value of y, it is 0, and value of dy by dx when t is pi, cot pi by 2, it is 1 upon tan pi by 2. So this is minus 0. So that is 0. Okay. Now after getting this table, these are the special points and these are the tangents at these special points. Okay. So we will draw the special points along with the tangents while tracing the curve. Now the next part is the region of absence. But here region of absence it is same because the value of y is same as y equal to a into 1 plus cos t. That is nothing but y equal to 2a cos square divided. This is always positive, and therefore as y is positive, it means curve lies above x-axis. Okay. So while tracing the curve, we are going to take care of this region of absence. Now we will trace the curve. So the last part is shape of the curve. So while tracing the curve, first draw x-axis and y-axis. Now we will plot at least 3 points. X is minus a pi and y 0. It means this point is here. So this is first point. Second point which we plot will be 0 to a. So 0 to a point will be here. Third point is a pi 0. So a pi 0, the point will be here. Okay. Now after plotting the points, we will draw the tangents at these points. So at minus a pi 0, dy by dx is 0. It means at this point, tangent is parallel to x-axis. So this line is tangent. So if x-axis itself is a tangent at this point, the nature of curve will be either like this or like this. Similarly, at this point, a pi 0. So a pi 0, again dy by dx, it is a 0. So at this point, tangent is again parallel to x-axis. So x-axis itself is a tangent. If x-axis itself is a tangent, then the curves are like this, either on this side or it is on this side. But in region of absence, we have seen as y is always greater than 0, the part of the curve which lies below x-axis, we are going to erase it. Okay. Now, next point is 0 to a. So 0 to a means this point. At this point, dy by dx is minus infinity. It means at this point, tangent is parallel to y-axis. So y-axis itself is a tangent at this point. So the probable curves are like this. So either on this side, again on this side. Okay. But part of the curve lies below this point, so we are not going to extend above this point. So this is the final shape of the curve.